That works. Alright, so let's go over DNS. And let's have a look at it. I'm going to go through 3 different configurations. Cache-only server, a master server, and a slave server on DNS. We're going to look at all 3. We're also going to look at the actual DNS breakdown here of how this stuff works. So first off, let me break it down. And this is on page 846 in your book. And this is the DNS bind server. The name of the server is bind. And I just want to start introducing you to some of these commands that are pretty useful. And let's see if I can only click on something here. There we are. So let me type in clear it out. Alright. Now if I dig Google, because Google is awesome, I totally dig it. So if you want to dig Google, do that right there, and bam, you get a bunch of information back on them. Which is to say nothing right now, considering, that's right, we're not online. So let me dig myself, since I can't dig Google because I forgot I'm not online. I'm being stupid on that. So if I say localhost instead, I can dig it. And what I dug, you can dig it too, don't worry. We have all the stupid puns we can possibly throw at it. Alright, so we have localhost here, dot. IN stands for internet. By the way, this is on your final exam, so you may want to pay attention to it. A means address. Okay, so check it out. Localhost answer here for internet. Single A means IPv4 address. Alright, and in this case, it's loopback 127.0.0.1. So there's our loopback address. Now, here we have localhost dot here, and then we have our time to live, everything. It's an internet address, and S means it's a name server, and it's localhost dot. Alright, so this is the actual address. We'll get into what these dots here mean in just a second. And then we have our additional section here, localhost dot. IN quadruple A. Quadruple A means an IPv6 address. Okay, and the the address for the IP address for IPv6 is : 1 for loopback. Thank God they made that one easy, because all the others are complicated as all get out for the addresses. You get back in IPv6 one. We do an ifconfig here. Pull it up. I can even prove it to you that this address is an IPv6 address for loopback. We have our loopback, or LO, and its INET address is your IPv4 address, and that's 127.0.0.1. And then here's your IPv6 address, and that is : 1, and that is loopback in IPv6 format. Okay? I'm going to go over how I set that up. Just 1 second. Okay. Now, how do you go out doing this? Now, it's totally different for... there's some stuff that's really different for Ubuntu than it is for Red Hat, but we're going to focus on Red Hat for now. And one of the things we can do here is we need to yum install -y bind. On Ubuntu, you're going to do sudo space apt-get space install space bind 9 with a 9, like the number 9, literally like that, and that's what it is. Whatever. But on this one for Red Hat Fedora 17 here, bind is the name of the program. 9 is version 9 of bind, so that's what the deal is. And then here we're saying systemctl to enable it, and then we're saying named.service, because the name of the server for a DNS is called named. That is the name of it. Don't ask me why it's called that, but that's what it's called. So we say named.service, and then we do a systemctl space start space named dot service to start it. So after we enable it, so that way it comes up when we reboot or whatever, and then we tell it to start so it's running. Let's make it to run. And here is that wonderful sed command for editing the name servers and commenting them out on the fly here, and then redirecting it to another file, and then coming over here and echoing out the loopback for this name server to point to ourselves for resolution, and then that gets appended, and then I'm copying it over to replace the /etc/resolve.conf file. Okay, so what does all that mean, and what on earth did I just say? What is that we just did? So essentially, I'm going to show you the command hand way you would do it by hand normally that matches up with this right here. Okay, so let me scroll that down a little bit there. So this is really kind of cool. I'm just going to go into VI to look at it instead of gedit. I'm going to become root, so I'm going to su -- here, password, like so. And then I'm going to go in here and cd into /etc. And then the one I can edit here, I'm going to do a vim here. I'm going to say resolve.conf. Okay. This one is generated by the network manager. Whoa, did it change on me? Like, yeah, that just changed the file on me. Wow. This file is generated on the fly by another script, which is the sysconfig network one. Hold up, I have backups of it. Thank God I did. Wow. Alright, so here's the backup one I have. And this is what I had at home, which is what you're more likely to see. Jiminy Christmas. Okay, yeah, I agree. I need to do a vim on that. Alright, so this is what you expect to see, and this is what I got home. Like I said, this file is generated on the fly. So it created a domain here, hsdl1 here .ga.comcast.net. And then here we have search. We're going to search this server for the name resolution. And the two places it looks is 75.75.75.75 and 75.75.76.76 for its name server. And those just happen to be the IP addresses to those name servers from Comcast. Okay. Now, instead of going through theirs and finding internet addresses or whatnot, I actually pointed to myself because I made my own DNS name server, and I basically use my own server to look up addresses on the internet instead of using the one from Comcast. So the reason why I want to do this, and this is really deceptive, and let me explain how this file works. And this is why this is so important to do this when you're setting this up. It is going to be name server. Name server is pointing to your DNS server, okay? This is client side. So if you want to test your DNS server, you need to do this because you have your client that connects to your DNS server, and you actually have a client running on your DNS server right here. So this is exactly what we have here. This is something you always do out in the field. And then to do better, further testing, do it from another computer too, which we can't do in the lab because we're using VMware. But if you had multiple virtual machines, you could do it then you could do it. But essentially what you do then is be tested. Make sure you also edit it on that client machine that is pointing to your name server. That's the key on this. Reason why we have these others commented out, because the way this works is that it tries the first one. If it fails to resolve the web address, it then is fails to connect to the DNS server, and for it to work, it then goes to the next DNS server and then the next one. So it's great if one goes down or if one is out of order. It has backups. Does that make sense? Yes. No, without the pound sign. And by default, it doesn't have the pound signs there. That's why I was using the sed command to pound out or to comment out these lines so that they are not live. Does that make sense to everybody? If you don't do that, Exactly. This will kill you when you're setting up a DNS server out in the field. Oh my gosh, you think you have it running, and your server out flat does not work. And does not run at all. Okay? And the reason this is happening is because it goes to your server fails to work, and then goes to the server that does work, and then works on the server that does work. And you think that your server is resolving all these DNS addresses when in fact it's not resolving anything. So this is a gotcha for a lot of network admins when they're first learning this. Make sure you comment out all other DNS servers so that you are the only DNS server that you are trying this with, so that you absolutely know that it is failing. Otherwise, you will get a false positive, meaning that it will fail on yours and then work on another one, and you think it works on yours, but it's not. Does that make sense? So be very careful of that. That is a big gotcha, and it will totally get you. And as you just saw, this file is generated on the fly by the scripts for whatever's connected and everything. So that script changed on us. So I'm glad I did this at home and captured it, because otherwise, since I'm not connected to the internet and it wiped out, that really sucks. So, it'd make a big difference here as far as that goes. But so essentially that's what I did. I commented out anything that was a name server at the beginning of the line. So if it was already commented out, it didn't comment it out again in my set script. And then I inserted name server here, 127.0.0.1, programmatically to the end of the file by appending it with an echo. Does that make sense to everybody? Now, I could have gone in here and just edited it, but I was trying to automate some of this stuff and show you how to use it to automate stuff by actually going and have it editing scripts without you having to go in and edit the script. So you can just, run one script and it goes in, sets up the servers, installs them, and then also edits all the scripts. So you have to do minimal work. I was going to have it where you could type in, different values into variables that it asked you, prompts or whatever, and then it just sets up the server for whatever distribution of Linux you wanted. That was my initial idea. However, I found that doing set on certain particular configuration files was particularly nightmarish, difficult, and I'll get into that in a bit. It's not as easy as it sounds on some of this stuff, unfortunately. It depends on how it's laid out in the configuration file, how they formatted it, and it can change on the formatting depending on what server it is, all that fun stuff. So unfortunately, things are not always straightforward, and that proved to be the case on some stuff. So with that, that lets you do your resolve so that it points to the right location when you run it. And of course, our problem was that I don't have an internet connection right now, so I get a DNS address of nothing. It generated nothing. See, because we don't actually have an internet connection. So, but if we did have one, it would look like the other one I just showed you. Okay, and that is how you would set that up for the resolve. All right, let's explain how a web address looks. Now, you may notice something completely different than what you're used to. You're probably going, what on earth is this dot at the end? You keep seeing it over and over again. I keep talking about a dot at the end. That is correct. That is actually the real address. The addresses you type into the web browser at the address line is not the actual address. It is the unqualified domain name. Once you put it in, it adds the dot automatically for you and makes it a qualified domain, fully qualified domain name, or FQA. FQD. Yeah, that one. Fully qualified domain name. Yeah, FQDN. Yeah, that one right there. So, what's that? No, you're fine. Alright, so now this is going to mess with you. The way we read these addresses is backwards from what you're thinking. You're going to read them from right to left. And that might sound crazy. If you look at page 847, and I'm just going to kind of point this out as we do it. Here. And they got some really great examples in this book. So, but, alright. So you'll notice here that the dot is the top root address. Now, Okay, so historically, let's talk a little bit about where DNS came from and why type thing. Originally, they used to have an address list of all the different servers on the internet in a file. I'm not kidding you. That's what they used to do. Why? Because early on the internet, it wasn't that big. So that wasn't really all that ridiculous to do that. You had some universities, some military sites. That's about it. You know what I mean? As far as that goes. So you really didn't have this big internet like we have now. So, you had like maybe 1,000 or two places, and that was it, Early on, maybe a few hundred, but that's it. But once the internet started growing, it started getting out of hand. And they started realizing, hey, updating this list is going to be ridiculous, and we can't do it. So they came up with DNS instead, this multi-distributed network system, and it was way more complicated than the initial just list thing was. I mean, we're talking like they made a light leap, as far as just this major jump from one place to another for technology-wise. And the DNS has been so good that they've never had to change it. It's been so solid and so awesome that it works perfectly fine, and it's what everybody uses, and it just works for everything. I mean, there's nothing bad about it. It's awesome. So one of the things, the way this works is that we actually have a multi-server lookup system, and you have to register it with what's called ICANN. ICANN is the association where it registers names for IP addresses for the different types of servers. So, for instance, you have a .com server, you have a .net server, you have a .org server, you have a .biz server, you have a .edu server, you have all these different ones from ICANN, right? And each one has its own listing. Now, ICANN doesn't point to all the different locations of all the different servers or whatever on, for instance, Comcast network. All right. So for the .net server with ICANN, so the domain server, dude, that one's just like basically stored because this stuff gets cached on your computer, so it doesn't have to constantly look up stuff that's standard and common. So what happens and what's common is that the root server gets cached and you never hardly ever hit it. But the root server basically points you to either the .net server for ICANN, or the .org, or the .edu, or whatnot on the hierarchy. Does that make sense? So in the hierarchy, just like it shows in the book, you literally hit the one first at the very top, right? And then from there it goes down and points to either .com or .net or .edu or whatever, depending on which one it is. In this case, it's the .net. So then it sends you to the .net one to look up the address. Does that make sense? And then the .net one tells the person trying to find blah 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 website or whatever where the DNS server is for that website. It doesn't tell them where the web server is. It tells them where the DNS server is for it. Is this making sense? These are all DNS servers. So it tells us where Comcast's DNS server is. And then Comcast DNS server tells us where the GA server is, which tells us where the HSD1 is. So this goes to a DNS server that takes us to another DNS server inside of Comcast because it's such a big company that then points us to the actual computer. That last one right there is the actual server and is the final computer.
And that's just for reading the name backwards.
Yeah.
The IP address is still read.
Oh, once you get to the last one, you get the whole IP address. That gives you the IP address, because once you get to that last location, it actually translates it into the actual IP address that is that server, because it knows. Yes, that happens at the DNS server. Correct. Yes, the DNS server is the one that does. The only thing a DNS server does is two things, really. Honest to God, it does two things. It takes a name and converts it to an IP address, and takes an IP address and converts it to a name. That's it. And the whole reason for it is because you don't want to remember that Google is 10.54.567.34 or something like that. Oh wait, that one's busy. Let's use 10.15. You know what I mean? Let's just keep all the different Google servers, in our heads as their IP addresses for it. Now I want to go visit redhat.com, or well, it's, instead of doing that, I'm like, oh well, I'd like to do 25 dot blah blah blah. You know what I mean? So for people to be able to actually remember the stuff and be able to actually surf the internet, they came up with DNS so that way people would have names that they could register to. Early on, there wasn't names. You did type in the IP address. That is how you surf the internet back when. Like that craziness I was just talking about, that is how you used to do it. They used to have BBSs and all that stuff. They didn't really have a web page, so to speak. It's really kind of stupid, but people loved it at the time. It was cutting edge at the moment in time. But it gives you the idea. So it literally has that whole breakdown, and they're showing these different root levels and top level domains, second level domains, etc.
The root server would be between the top level, or the root domain and the top level domains, right?
Yeah, that's from ICANN. Root domain is ICANN, so is the top level domains. Those are all ICANN. The root one is the main server for ICANN that then points to the other servers. Of course, the .com one's got to be really beefy because that's the one everybody wants to use practically. Yes, there's some on the other ones, but they're like minor comparatively speaking to .com. Yeah, ICANN, double N, ICANN. It's actually in your book too. It stands for something, I don't remember what it is. Is this making sense so far? Okay, so let's go down, let's go deeper with this stuff, okay? If you look on page 848, you'll even see a breakdown of this, where it has root domain is the dot, it says top level domain is your com here, your .com, period separating the parts of the fully qualified domain name, or FQDN. Secondary, second level domain here, so Bell in this case, and then subdomain or host name, aka the computer. In this case, it's not going to be a subdomain. Wiki is the computer, that is the host name, as it's called. Your server would be your host, unless you're talking about Microsoft, and then they really confuse things by calling servers not hosts. They call them clients, hosts. I don't know why they did that. It drives me nuts. Yeah, host. That's what I heard in the past or whatnot. I always think of host as the server, but anyways, the host here is going to be your wiki. In this case, it's really just confusing. But if you standard standard Unix and Linux, what always been, host means server always. Okay, and client means client. We just call them clients. So okay. So that's the difference. You can have zones. You must have one zone per domain. So for instance, like a .com has its own zone. The root period has its own zone. So on and so forth. Like so Bell's going to have its own zone. So on and so forth. You can have multiple zones within inside of a domain, but you must have at least one zone per domain. Okay. So okay. All domains within a zone. And they have an example of that on 849. Alright, let's talk about how we actually resolve a query. And this also ties into how people can attack your DNS server with denial of service by just basically making you do tons and tons and tons of lookups with a ping attack. Ping of death, as it's called. That is what it's called. It's an attack from hackers. That's why you'll see some servers not even respond to pings on purpose that are on the internet in order to avoid a ping of death attack. If you ever ping something and it doesn't come back, but you know the server's there, yeah, they're not responding to you on purpose. Because they've been pinged to death, literally. What they do is they get like thousands or hundreds of computers to ping a single computer until they crash it. Over and over and over and over, constantly. Yeah. A lot of the attacks really aren't that innovative or inventive, but they just find ways to just annoy the crap out of network admins. But okay, so let's talk about it. Now we looked at the resolve.conf script, right? Because that goes to the resolver, as it's called. And that's why it's called the resolve.conf file, because it's the configuration file for the resolver. Resolver is what sits on your end of things, and the resolver is what's on your client machine. All right, so it's the program, if you will, or the client side program that sends the request out to the DNS server. It says, hey, I want to look this up. So let me give you, for instance, here, and this is going to work because I'm going to use localhost, which is fine because this is all tied in to what we're doing here. Yeah, I know you can't find anything right now. But it's okay, we can find one thing. Alright, and that is our web page. Alright, localhost. When I typed that in, it actually did a DNS lookup. Now, this is kind of boring because it's just localhost and it's not a full online. But again, we're not going to have our own registered online set up tied to our virtual machine from the internet, registered on the internet with ICANN. Okay, so we're going to use localhost because that's what is on our system. Does that make sense? And we can network with ourselves that way, and then that just makes life easy. So for that reason alone, it's a good one to go with. But you know, if I did that, or I'll give you another example, like www.google.com. Right? Say I were to enter that and I went to that. Of course, it's not going to work because I'm not online. But say I did, and it came up with Google. Well, what's happening is this is sending, the resolver is sending this to whatever DNS server. And in this case, it would be my own DNS server. And when I had to set up at home with the internet connection, it actually did go out and find it and work. So it did resolve it, and it did work beautifully. It's nice. When you guys do this on your virtual machines in the lab or whatever, it will work because you'll have an internet connection, and then you'll be able to resolve your own internet connections, your own addresses with your own DNS server. So basically what the resolver does, it sends it out and says, hey, I want to go to www.google.com. Okay? Alright. Sounds great. Or actually, if you were to do a dig on this, you're going to love this one. There, that's the actual address for Google. Yeah, you didn't know that one. That's the actual address for Google. It's www.l.google.com. Yeah, that's the actual address right here. I'm add a dot to n. That's the actual address for Google. They use a name server, a CNAME, in order to place www.l.google.com. So you can just type in www.google.com, and it basically translates that into www.l.google.com automatically. And they have about 6 servers they have supporting this thing. If you want, you can dig Google. You can dig it, and then you'll see all those different servers, and you'll see I'm telling you the truth when you do it. So just dig it, and you'll see it. All right. So from here, I love dig it too. So basically, with this, what's going on is it goes, all right. So the resolver sends it to the DNS server and says, I'm looking for www.google.com, for instance. Now let's do www.l.google.com, which is crazy. You wouldn't normally type that in, but let's say we did. Okay. Well, what's going to happen? Well, it sends it off to the DNS server, and the DNS server is going to do the work on behalf of the client-side computer. Okay, so the client-side computer is not going to do this whole lookup thing. The DNS server is. And there's a difference between two different ones. There is a recursive lookup when you're doing this recursively, and there's another type of lookup. Iterative, thank you. Iterative is cheap, recursive is expensive. Each stage and step of this is an iterative lookup. Recursive lookup is the entire process of looking through this whole thing to find it. So essentially what happens is it goes, for instance, the DNS server on behalf of the client for the resolver goes to contact ICANN for the dot one and asks the dot ICANN server, do you know where www.l.google.com dot is? And it says no, is its response. It says, but I do know where .com is for the address. So it sends back the address to .com to the DNS server. That is one iterative lookup. Okay. The recursive is this entire process. So let's go to the next part here. Then the DNS server contacts .com server, okay, from ICANN. It says, do you know where www.l.google.com is? It says, no, but I do know where the Google DNS server is. So it replies back with the IP address to the Google DNS server. All right. So, and so that's another iterative lookup. Each one of these is a separate iterative lookup. Is that making sense? Okay. And so then it goes to the Google DNS server and goes, hey, do you know where www.l.google.com is? And Google's DNS server says, no, but I do know where the L DNS server is. So let me redirect you to that. So it gives it back the IP address for that iterative lookup. All right. And then the DNS server says, all right, do you know where www.l.google.com is? And it says, yes, I can tell you where the www server is. I know exactly where it is. And here's the IP address. And then the DNS server takes that IP address and sends it back to the resolver client saying, here's the IP address for that server that you were trying to find. And then once it goes back to the client, it then brings up the web page because you didn't access it. And it does this all in a matter of milliseconds. That whole process I just said is the recursive lookup. Yeah, for it. So the thing about the DNS servers, you don't want your main server getting hit to be the server that does recursive lookups. You want to do nothing but iterative lookups only. Because if you do recursive lookups on the main DNS server, you're going to crash. There's going to be an attack on your DNS server. They will flood it, overload it, and it'll crash. So what you have to do is you have to shunt it off on other secondary servers to handle the actual recursive lookups. And then you only do iterative lookups on the main DNS server. Does that make sense? So when you're doing DNS servers, realistically, you need more than one. You need several. Because you have to be able to handle an attack on the network. Because realize anyone can basically do it. And then once they do the attack, oh gosh, they can cause it to overload. It floods as the different entries go out of the company. And then whoever's trying to break into the company can then see what everybody's trying to search for and look at and do on the company, where they're trying to go and what they're trying to see, what they're trying to work on type thing. So it's to get information is the whole point of doing those attacks. Because once that server floods, because what they'll do is they flood it, and so it no longer gets cached anymore. Like, remember how I was talking about this caching stuff or whatever? It no longer gets cached anymore. And they have to do full lookups after that, because whatever they're sitting there slamming it with over and over again ends up filling up the whole cache. And then there's nothing else in there. So kind of matters about that whole thing. It really kind of sucks what they do. It's dirty, but it's the way it works. So be aware of that. For security reasons, you may want, if you're really on a security type setup or something of that nature, you want your DNS servers in-house inside the company. This way all the DNS lookups are done inside the company and it never actually goes outside of the company for the lookup. Does that make sense? The whole iterative process is handled by the DNS server inside the company, and what people are actually trying to look up isn't handled outside the company. Now, right now, if I was to go at home, I'd be connecting with the Comcast, and someone could actually sniff what I'm doing back and forth between them, right? But if I had it set up inside my company where I'm doing my own DNS server, someone can't even see what I'm looking up, what I'm doing. They can't sniff in between, because my DNS server would be connecting with the other DNS servers, and thus bypassing that. Does that make sense to everybody?
So you're saying that your internal DNS server would be passing the queries off to secondary DNS servers which are outside of your company?
Not necessarily. No, typically your secondary DNS servers would be inside your company also. Yes. So you'd have your primary DNS server in your company and the secondary ones too. And they would all be in your company, and then they would do the lookups for your employees for whatever they're trying to look up on the internet. And also would handle external parties looking up your servers for your online aspect, but it has a dual function because not only can it handle people from the outside trying to access your web servers, but internally you can have your employees find the other servers on the network for networking operations and or other completely different web page Apache servers out on the internet. Not necessarily Apache, but just web servers in general, and connect to their DNS through ICANN. Does that make sense? Okay, what part makes sense and what part doesn't make sense? Right, you're having to. Yeah, they're still going out. They are getting redirected to the web server or whatever for lookup, if you will. Huh? Well, I mean, they're not going to know what the other servers are on the network, so to speak. I mean, ICANN is going to point them to when they look up www. Whatever, the www is the server, so it's going to take them to that one versus that of something else. I mean, I guess it's up to you for what they can see or whatnot. Oh, they still can get pinged, attacked, or whatever. No, you can't protect it that. You are going to get hammered on that. That's why you have to have several of them. That's why I'm using the uh, Amazon Cloud servers because it's 50 cents for 10 billion hits on the set of servers. Yeah, yeah, they're a super cluster is what they are for each one of those. So I get 4 super clusters. It can handle any kind of ping. I don't even have to worry about it. They got tons of DNS entries essentially on those DNS servers as superclusters. I'm not worried about it. But on the other hand, that DNS server is not inside the company. So if someone were to connect to it from outside our company, someone could sniff in between it. I could set up a DNS server inside the company just for the purpose of searching web pages that doesn't even point to any of the servers unless it's just internally. And then that DNS server is not even connected to ICANN at all. And in which case, then an attacker couldn't just come to the DNS server because how are they going to go to something, if that makes sense? So they wouldn't be able to find it, more or less, on the internet. Because there wouldn't be an address with ICANN to find it. Yes, it's a private DNS server inside of a company, and a lot of companies do that. So you could have a dual setup here. I'm going to show you the Amazon one later here. But you could have like your Amazon for your public one. You know what I mean? And let's face it, 50 cents a month. Dude, you can't beat that. You cannot. It'll cost you thousands and thousands of dollars, comparatively speaking, versus the 50 cents a month. I'm not kidding you. It's going to. Because you're going to have multiple servers. And in this case, they have multi-server networks, and they give you 4 multi-server networks, essentially, different locations around the world. 2 in the US, 1 in London, and I think 1 in like Singapore or something like that. Right? So you can't beat it. You can't beat it for 50 cents a month. I'm not kidding you. For 10 billion hits. After that, the next 10 billion is another 50 cents. A lot of people do use it. A lot of companies use it. Yeah. A lot of companies have their servers up on Amazon. A lot of companies, this is how cheap it is. It was so cheap that mid-sized companies were selling off their servers and going on Amazon Cloud because it was cheaper than running their servers. They'd already bought them. It was cheaper than running their servers with electricity and the cooling than it was to pay Amazon for the virtualized servers. Yeah. Well, it's not 50 cents for like a web server or whatever, something like that, but it is 50 cents for the DNS server. No kidding. And so, yeah, dude, it is the wave of the future. A lot of companies have gone that way. So, for obvious reasons. It's on Amazon's networks. And like I said, they have 4 of them, so it's redundant.
It's just the data's all distributed in various locations, right?
And then you list those, and you list ICANN those servers to ICANN, and ICANN can send them regionally to those different servers. So even if one's down, ICANN still can send them to another one. So you put in those different servers or whatnot, and then it gets registered with ICANN. You don't just necessarily have to register one DNS server with ICANN. You can register multiple for a single address. And that's typically what you do. You typically have more than one DNS server that you register with them. Does that make sense? Yeah. So, really powerful, really cool, and quite amazing actually, when you think about it. That's essentially how that works. Now let's start looking at how to break this stuff down and do configurations on it. I think I talked about some of the stuff. I'm going to talk about some more. We're going to talk about some of the specialized symbols and all that fun stuff and whatnot. Essentially, I'm going to take your labs and break them down all together. Here, I'm going to show you how to do them one after another, and just break them out. And then you can just do the configurations and screenshot it. So I'm just trying to make your life easier. This also shows you how to do all the different setups and configurations here. So, and I did test it. So first of all, let me show you the master one. It's not the one, of course, they start out with a book, which doesn't make any sense, which is a daggone reason why I'm going to do the one that makes sense to do first. And that's the master one. You always have to have a master server before you can have your other ones. The other ones feed off the master server. The master server is the main server. Okay, so you always have to have at least one master server in your DNS network. If you do not, you don't have a DNS network, because the others have to connect to it. If you don't have one, that will be a problem. Does that make sense to everybody? Okay. It doesn't matter. I'm going to do it in the video. But if you really want, the page in the lab book, I think, is 167. But, you know, it varies here. And I'm just going to show you real quick how to do this. But, again, you don't have to worry about it. Did I just hear snoring? He's at ease. Too much. Too much at ease, soldier. Alright, so from here we have named.conf. Alright, so I'm inside of etc, and I just I did vim named.conf here, okay? So this comes up. And this has several different things in here that we need to take note of. And here underneath the zone information, notice that is IN for this. We can set something in here. We already have the file here. We have the type here is hint. We can change the type from hint to something else. We can change it to master. Now, what I'm going to do is I'm going to comment this out because I don't like to remove stuff, if that makes sense. So that way I can go back and reference it later on if I like. So hopefully that makes sense. I'm just not a big fan of deleting something once I have it in there. Alright, master. This makes it a master server. Make sense? The file here, instead of being named.ca, which is great and all, but I can do that. And what I can do is I can call it class zone instead here, is what they're doing with theirs. Yeah, it needs to be in quotes. Because this is text string. And then this file has to exist, though, on the network. Otherwise, it's not going to do very good. Now, and then we can edit this file or whatever after that. So this basically sets this up like so. Shift, hit escape, shift ZZ to save. And if at any point in time you want to make it restart and refresh something, systemctl. I'll show you several tricks here. Restart space, and then we're going to say named dot service, and we can check to see why it failed. Probably because of what I just changed made it fail, because what I had worked. And then so yeah, it shows us where the failure is, and it's in the name.conf. So this is what's cool about this. So you can use the status thing here to tell you all kinds of information about what's going on. And I have no doubt it's what I just changed that it didn't like. So I had a working server and I made it not work. So let's change that real quick so that it works again. So even though they want to be class zone, it's fine if it's not. It's fine if it's what was a second ago. So this is again another reason why I don't like to get rid of this stuff. Wow, does it want to be hint? Unless it's throwing a fit that we're not online. Yep. Okay, leave it like I had it. Don't change that. But normally you set that to master for the zone here. This is a special configuration though that they have for this school one, and we don't have the same configuration. So we can't do exactly what they want us to do, unfortunately. Because they're wanting us to set it up as grape.class.example.com. And we don't exist as example.com on the internet. We don't have that, so we're not registered with ICANN. So I really don't see how we can make that one happen. Just saying. I'm used to doing this stuff for real and not for fake. I'll show you for real later here on the Amazon Cloud. It's the exact same stuff. Okay, but this is not for real, so we're going to do a not for real setup. But it still does all the same stuff. Okay, this is how you would really do it, only you would do it with a blah blah blah.com or wherever it's registered with ICANN. You would be registered with ICANN, your DNS server would be registered with ICANN, and you would have to have a static IP address for this. DNS servers cannot have dynamic IP addresses. They have to be static, always. Does that make sense to everybody? Your servers must be static IP addresses. So you have an Apache server that's connected out to the internet, whatnot, it has to have a static IP address. You have to pay for it from the blah 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 phone company or whatever company is providing your internet connection. It must be a static address that you pay for a company. If you don't, you can't have like one of these like from Comcast, wherever like you get for regular personal, where it changes every time you connect or something of that nature. It must be static. It must never change, because the reason why is because if that router has to be restarted or something like that, you do not want to be issued a brand new IP address, because if you are, then when someone tries to go look up your web server or whatnot from ICANN, they go to look it up for the DNS server, and it's no longer there at that IP address. And then you have to go in and guess what? Edit the IP address for ICANN. You're like, oh, no big deal, right? Nah, man. It is a big deal, because what happens is remember I talked about the DNS servers caching this stuff? They do, and they cache it for like 4 or 5 days typically. So what happens, and this is one of those gotchas, and this is something I should point out too in the real world that's not going to be in your book. When you are changing from one web server to another one, and they are different, and you're moving the domain from one domain name server, from one DNS server to another DNS server, give it 5 days at least. I recommend something like 7 or 10 days just to be absolutely sure. That'd be a ridiculous amount of time, but just be absolutely sure anyways. You need to run 2 web servers simultaneously. You must have 2 web pages going at the same time at once. No kidding, you do. In order to do the transition. And realize people are still going to be hitting the old one for about 5 to 10 days. Because even though it's changed up on the ICANN servers and is now different, people aren't necessarily hitting the ICANN servers. They're hitting these other servers where it's cached, and they'll keep getting that cache until it clears out the cache. And that cache, clearing out the cache can take like 5 days easily on these different servers. So depending on where you're at, and suddenly, eventually, the other page will suddenly pop up. So, I mean, this is one of these things that always gets these people. A lot of people think you can just go, oh, I'm just going to change from this one over to this one, and no problem, blah, blah, blah. I'll just shut down my other web page. Okay, if you do, realize it's not going to be there for most people. 90-something% of people are not going to see the web page you have. Yeah, they're going to think you went out of business for about 5 to 10 days. It's just not a good thing. Also makes you look stupid and incompetent and unprofessional. But I'm just saying that happens all the time, and be aware of that. It's not instantaneous. Okay. So, let's look at how to edit this file. So first of all, I need to go into my var here, and I'm going to be looking up the named folder. And if inside of named is the name server here, and we got different ones here. We have name.mp, here's name.ca. It's probably why it's throwing a fit, probably because it wanted one of these, and we didn't have one for the class.zone. Remember how it had to correspond with a particular file or whatnot? So that's always useful. And here we're getting a whole set of information here. So everything from m.root-servers.net for ns for namespace, so on and so forth, and all these different ones for it. Here's the one we're actually going to use. This is the one that's actually our server for our local host. Does that make sense? Alright, so TTL, there's time to live. And set to 1D in here. And I need to change it. And I swore I did change it, and I probably did. And it has done something else since then. It helps if I type vim correctly. Alright. Then I come in here, and what they're wanting us to do is change serial from 0 to 1. Which I could care. This is your SOA, or start of authority, as Cartman would say it. Start of authority. In at here our name.invalid. And we have a serial. Now, you can put this all in one line and do it in compact form. I hate that. I really prefer this method right here. And realize that the single semicolon here is a comment, because I think this is like a Perl script or something like that. But anyways, the semicolons here are comments. And so this is 1 for the serial, 1 day for refresh, 1 hour for retry, 1 week for expire, and 3 hour minimum. Make sense? That's what these letters are right here. And then you can see why the comments are nice. To go along with it. And you can see why laying it out like this makes it easy to read. So by all means, please do it like this. Don't do it in compact form where you can't freaking read it and there's no comments. That's a bad way to do it. So that's what start of authority is. And basically just lets you do performance tuning of your DNS server. You change these values to tune it however you need to tune it. So like you realize, you know what, I really need to make my minimum 2 hours instead of 3 hours because I'm not getting the response I need on it or something like that, and it's causing too many problems. So then you change it. Does that make sense? You get to find this out while you're running stuff. That's what you need. Just go with default values for the most part, and then if you need to change something, change it. But defaults typically work well. NS is your name server, and here's your @ symbol. MX. MX is your mail server and points to it. NS is going to be your name server. And I'm not sure if they even... Okay, yeah, so they have a good example of it in here. So their example is something we can't do. They keep going over doing this example.com, and I can't do example.com because example.com isn't going to actually be live and wouldn't actually work. So that's why I'm sorry. That's why I'm not having you do what they're telling you to do. Okay, because it won't work if you do it. Example.com is quite literally an example. That's why it's called. Oh, sorry. Yeah, that's right. Not we have to do it that way. Sorry. Sometimes it's a semicolon. Sometimes it's a pound sign, depending on what type of file we're doing. Of course, it's hard to tell if they're using Python or if they're using shell script because both are pound for comments. Whereas Perl, I think, is a semicolon for it. So I think they're using Perl scripts for this. But anyways, what they're wanting us to do is say something like class here dot example dot com dot and then ns, and then in this case linux dot class dot example dot com. And that's a name server. So it's translating class.example.com into linux.class.example.com to point to that actual computer. Does that make sense to everybody? Okay, so that's basically that's your name server. Your name server is another way of saying a DNS server. That's why it's called a name server. It converts names to IP addresses. All right, and then the other thing, and so that's a different example. Of course, this is total BS, so it won't work because it's just an example. So that's the one that's actually going to work for localhost. Okay, so we're going to stick with that. Huh? Oh, highlight it. Well, it looks like everything's showing to me. Yeah, no, that's the entry. There's nothing missing there. That's all there is. It's ns space @ symbol. That's it. Or tab @ symbol, anyways. Yeah. Right. Nothing's missing on this. This is the actual. See. It's not. You're seeing it straight up. MX here is your mail server. Now, typically, MX is going to be done a little differently than this. So again, I'm going to show you something that's total BS here. I'm just going to go ahead and start commenting it out to start with, right? I even set up a C name to show you kind of what this stuff would look like. But your MX here, go ahead and put it in comments just so you can get an idea of what it would look like type of thing if you're doing this example.com thing. If I could stop mistyping stuff, that'd be great. Alright, dot, and then you're going to say something like MX here, that, and then, or tab it, or whatever, and then do a 10, tab again if you like, or something like that, and then Linux dot, oh, I don't feel like doing that much of a tab, that's just too much. Linux dot, and tabs are nice because everything lines up, but on the other hand, it's going to start running off the side of the screen here, so class dot example dot com. And then dot for finishing that off. Alright, so what this says is, okay, this is where the mail server is. Okay, now I'm going to be honest with you. Typically, you're not going to have it like this, like what they're doing. Typically, you would have something like this, for instance, with the space between that and 10. But yeah, typically you'll have something like this. You wouldn't keep using the same server. You'd have a separate server for the mail server. You can even have multiple servers for your mail server. You can have one for sending, one for receiving. You have multiple sending, multiple receiving. You can do all that. Okay, get into it, but you can do that. So you could even have database-driven email, in which case then you could have a whole separate server for the database system separate from the mail server, which then gets its information from the database server, and it makes it faster and more efficient. You can handle like 10 times, 100 times, more like 100 times as many email counts on a database server on the same computer. Now, if you put it off on a separate computer, it's even better. You can probably handle more like 1,000 times more. It's ridiculous how many more you can handle. Instead of handling a few thousand users, you can handle like a few million type thing. So just a little bit of a difference there for what you can handle for a number of people and everything. It's amazing. So that makes a big difference. But I'm not getting into that. It's really complicated. All right, so what does the 10 mean here, though? So MX means mail server, right? And then 10 means something in particular. Well, the 10 here means priority level. All right, so the lower the number, the higher the priority, which may, create the wrong way in your thinking, but that's the way it is, right? And so if I do a 10, that's the one that's going to get served first. So it sets a priority level. And if the 21, if the 10 is full, it sends it to the 20. But at first, it's going to try to send it to the 10. Does that make sense? And so that's setting up your mail record. CNAME. I'd also like to point out that A and CNAME and stuff like that is on the final exam. So be aware of that stuff because it's on there. Yeah, some of the stuff I'm going over right now, it's on the final exam. So A is pretty obvious, really. Let me give you an example. I just need one example of this, really. But that's an example of your CNAME, where it's basically a substitute name, or shall we say, a nickname. Like you have a nickname, for Richard. Oh, that's not a good example. Let's see here. What's another one? No. For instance, Robert might be Bob. There we go. That's a better one. That's a nickname example. Yeah, let's not choose Richard. All right, so gosh. All right, that was a really bad example. All right, so from here we have grape. I'm just going to go ahead and comment this out so you can see it. Dot class dot example com dot. All right, and let's just say big A right here. So what does big A mean, guys? Can you remember? It's the IPv4 address. Yep, you got it. Good job. 18.0.55. All right, and so there we are. And then that sets up our yeah, when someone types in grape.class.example.com, it translates that into 172.18.0.55. Yeah. There's also a way to do a reverse iterative lookup here. Let me do a CNAME here too while we're at it. Different than the one I have here. The other CNAME I wrote didn't work. So it's commented out. But anyways, if I was doing something like www.class.example.com dot, of course, and then CNAME, like so, and space here, linux.example.class.com dot. I mixed that up. I'm sorry, that should be class. I was like, that really doesn't look right. Okay, yeah. I knew it. There we go. Sorry. That one. So it matches the stuff above. So essentially they have everything going to one server. They have this server is their Apache server. This server is their mail server. This server is their DNS server. You start to get the idea. This server is everything on their setup. If you're on a small company, they may have to do something like that. Your chances of getting overloaded in an attack are much higher though too. So that's the way it goes, right? Again, that's why I prefer Amazon Cloud for that, for your DNS server, so you don't have to worry about it. Anyways, after you configure this whole thing, then you can restart it. And I'd like to show you what to do with this. So I hit Escape, Shift, ZZ here. And there's a couple of things you can do. Let me show you how you test your configuration file to make sure it's all good to go. They actually have a testing tool for this, which is really nice. Named here, and then you say dash, and you say check conf, check configuration, all right? And what you're going to check your etc/named.conf file. And then if everything's all groovy, you get nothing back. If everything isn't all good to go, it will come back and tell you what's wrong. Does that make sense? Great tool. As another, for instance, here. The other thing you can do, of course, you would need to come in here at this point after you edit that thing right there, to come in here and say systemctl. You're going to need to say restart here, and you're going to need to say name.service, like so, and then you can check your status afterwards. And there it is. And then you can test your server too by digging it. So dig localhost, for instance, and this is what you should get if everything went right. You can also do host right here. This is another good testing tool. It's not as detailed as dig, but you can use the host one. If I type in host right here, and I type in localhost from there, and there it goes. It gives me my address. You can do crazy stuff too. You could look up for dig. You could look up. I'm going to use the -x option. I have to because I can't stand the other way to do it. And this lets me do a address lookup. So you can see how the address actually is laid out. So if I didn't do it this way, I'd have to type out the full thing. Full thing is .arpa.adder-n.127.0.0.1. It literally looks it up, and it actually has the same kind of thing where you go up to ICANN or wherever. In this case, we're not going to ICANN, we're going to ourselves because it's loopback. But it literally goes to an ARPA server up on ICANN, and it looks up the IP address, and it literally has the IP address stuff stored in ICANN too. So just look it up. So that's what the whole ARPANET is. So if you don't do the dig with the -x option, literally, how do you have to type this in? Well, it sucks. You have to do it like this. Why? Because this is the actual address. So -x option for your own sanity if you want to do a reverse lookup. Reverse lookup or reverse DNS, however you want to say it, that's where you take an IP address and convert it to a name. This is done all the time. You might go, why do I need that? Well, one thing, it's good for testing. Two, it verifies whether or not a email address is valid or not. If it's a real server, if it's coming from a real place. So you need to have that in there so you can show people that you are you're not a hacker. You're not a spammer. Because spammers, a lot of times, you can't reverse their IP addresses. Because that username and that address that it says it came from doesn't actually exist. It's not actually coming from there. Does that make sense? So for that reason, be aware of that. Alright, so that's essentially a master one. Oh, I'm sorry. vim/etc/named.conf. Alright. Yeah, and then the other thing I should have done too, by the way, I forgot to mention this. When they were setting up their zone, it was it's totally different than this thing right here. It'd be class here instead of for their master and class zone here. It was class .example.com. Like that for the IM part. Okay, so I think what I'm going to do, hold on a second, just going to do this real quick as an optional one, so that way we have it. And so what we can do here, Shift-Z. Let me copy this file real quick. How about that? Then we have our master configuration. Just go ahead and do something like that so that you can then show that off or submit that file. I don't care. Submitting that file would be great. That'd make life a lot easier. And then I can come back and go back to my other previous setup. And I'll be fine. Because we got several of these here, we're going to be doing a master one. We're going to be doing a slave one. We're going to be doing a cache only one. So because we're doing these different ones, I really don't want, to keep this whole thing here. Alright, so that was the master one. Now, let's look at the slave one real quick. And it's actually kind of easier than you might think it would be for it. So for this one, they did a little bit different, not much different, honestly. So what you're going to do is you're going to come in here, instead of being master here, you saw before, right? You're going to say type here. You're going to say slave, literally, semicolon, like that. And instead of them doing class example.com here, they just did example.com, like that. That's all they did. And then you have to tell it where the master one is, though. Because if you have a slave server, you must also have a master, because it has to talk to the master in order to get its configuration stuff. So you're going to say master like this, and then you're going to say wherever the IP address is for it. Now, in their case, they had an IP address that we don't have, so this is not going to work for us. But, I mean, for us, it'd be localhost, or basically 127.0.0.1. That's what it'd be. But we can't have both on here, so again, this is totally fictitious. We can't do it, type thing. But I'm just showing you. This is how you go about it. 254, like that. Alright, so say that was the IP address to the master server. It was a static IP address on the internet. Okay? Then I put it in for the master one, so that the slave server can connect to the master. And then in this case, the file name here, he has a different file name for it, of course. And this file here is space here. Alright. And it's slaves slash example dot slave. Whatever. Alright, so that's that. So if we hit escape on this thing, we can say Shift-Z to save that out. And then we can just do another good copy like we were doing before, and change that from master to slave for your name of it. Because again, we can't actually do this thing. So, hey, whatever. And then what we would then do after that, of course, we would restart this thing. I'm not going to, because it's not going to work if I do. But we also need to add a zone information thing where we can do this in reverse. So that's kind of cool. So hold on a second, let's look at that. So we need to add another zone. So we have our example zone. You can have multiple zones, that's fine. Remember how you can do multiple zones. So we can do multiple zones. I'm sorry. Let me hit enter here. Set this up. So we're going to do another zone. Only I could stop screwing it up. Thank you. Alright. And then remember how we had to do that in reverse? Well, guess what? We're going to be doing that again for their IP address. So we can't get away with it. We're going to have to deal with it backwards like this. And no, I did not make a mistake. That is how it is. They typically leave off the last number on purpose. Okay, so that's not a mistake, just so you know. Space IN, and then space, and open that one. Okay, and then from there, type is going to be slave, like so, semicolon, enter, and then master again. I wish I could copy and paste. I can't copy and paste. I'm too lazy to type that. Sorry, guys. There it is. Alright. And then down below, close but not quite the same thing as before. So I'm going to have to say file here. And then I'm going to have to say in quotes, and slaves, like so. Alright, slash 172.18.0.slave. There we go. End quote, semicolon, like so. Close curly brace, and then semicolon to end it off. Make sense? Okay. So that is literally it. You would then just basically save it. You do your check named type setup here. You do, what is it called? It's the named dash check or whatever, and you do it on /etc/name.conf file to check your configuration file to make sure it's all right. It's all good. Of course, I expect this to not work. Yeah. But it's saying, hey, this is going to work if we did this. And of course, this actual IP address and everything doesn't exist. So, sorry, it's named. I keep wanting to do it by named dash checkout check. Sorry, conf. Christmas tc/name.conf. All right, and again, it doesn't know option master here, so we're gonna leave that alone. Again, and then you would also have to restart it by doing the systemctl. Now you're not going to do any of this because you can't. Right here. You will do the files, however, but you can't do this part. You can't do the systemctl, and you can't do the name-checkconf for obvious reasons I just showed you. But anyways, come in here like so, and then we'd say, of course, those other files need to exist too that don't exist. That's probably part of the reason. But no, some of them aren't. Some of them you have to create yourself, which they don't go over. Named.servers here, and then that lets you basically restart that server. Again, I'm just going to run that CP to copy that over, so I don't have to do it again. Yeah, override, it's fine. And then I'm just going to go back to my previous setup here for my name.conf, as I do not want what they have in there. The other one that you can do besides the slave server is the cache server. And the cache only configuration. Alright, there's not much to do on this one, which is thankful. No, you would literally go in and write your own start of authority and all that, and you would write out that configuration. Does that make sense? Yeah, so you'd have to define out one of those files. Oh, what am I doing? Sorry, you. Alright, I'm getting back to the original here. Originally, this is what we had. Like so. See, works without a hitch. I got it. Systemctl space restart space named dot service. There it is. And I can run status on this if need be. Now in the case of the one with the CA, it was already there when we installed bind. For this zone. This zone was already there. Does that make sense? So, I mean, the only thing you would go in then you do is to change the whole. Alright, hold on. Let me go over this cache server and then I'll go into it for a second here. Alright, so the cache server here would be vim here /etc/named.conf like this. And then you come in here, and then the things you'll comment out be like listen here. So you comment this one out, comment that one out. You would comment out this allow query here, and you would comment out all these DNS sect. Okay, so this is your cache only setup. And then the only thing you would do is add forwarders. And you would forward this to another location, for instance, for it to do the recursive. So you would sit here and say forwarders. See how it highlights up for us? And I think that's a space. And it's going to be 172.18.0.254. Like that. And then you would save. Like that. and that lets you do a cache-only server. So that one's pretty simple. And then let's just copy that to be a cache-only server. So it's this slave. Let's call this cache. All right. There we go. I'm going to go back and edit that back to where I want it. So I really don't want that, to be honest. Because I do want this to actually do the full recursive lookups. And you will too. Okay. That is how you do all three of those. Right there. Alright, so from there, I can even do the check name thing. Came out good. Okay, good. Status, yay. Restart it, blah, blah, blah. Alright, the actual server, of course, is held in var/named for the being the DNS bind server. You got different ones in here. You can look at, and here's the slaves one folder we were just doing a second ago. So if we cd into slaves, we'll see it. Of course, there's nothing in there. We'd have to create those files themselves. We can cat different ones here, like we can do name.empty, and it gave us these on the fly. So this is just start authority. This gives you a nice starting one here. You can cat another one, which would be named .localhost, so on and so forth. That's the one we were playing around with. You can also cat named loopback, like so. You can change its start of authority. Now the one that's going to be different is going to be the name.ca. And this is the actual lookup, I believe, of the different ICANN servers, if I'm not mistaken, for that. So don't play with this file. But it's got a lot of stuff in it as far as that goes. And so it defines it out as an internet address. It's got the IPv4 and IPv6 addresses, so on and so forth. That's the main thing. We can go in here and basically create these different file setups and whatnot for configurations. Webmin, we used to use it, and I'd show you guys how to go in there and set up a master, whatever, in there graphically or whatnot, as far as that goes. But this is how you do it through command line and edit the files. And this works because after you get it done and it all works and everything, you can then dig your server. Can you set up the connection? Okay, I'll show you one that I have live on the internet here in just a second. And you'll see it's the same stuff. It's the exact same stuff I just went over. Only we're doing it on the internet. It used to be a nightmare to do it, and now it's easy as all get out. It's same information. It's not dumbed down or anything. But it is real easy to set up. And it's fun just to show a real configuration. Alright. The PTR one, sorry, the PTR is your pointer for doing a reverse lookup, by the way. Okay, go ahead. Okay. Oh wait, I need to do it over here. What's it called? That one right there? Okay. Alright. So while it's connecting, real quick, let me point out one more thing here. And that is how to do the reverse lookup, because it is a PTR on that one. I do recommend doing these. Not everyone does that, and I really don't understand why not. I think it's just a complete type thing you should do. Right, so besides this quadruple A here, you can also do a PTR, and the PTR is your pointer, which is a reverse lookup, okay? So this one matters because what you'll do here is you'll put your address that you want for this thing on this part right here, so like 127.0.1 type thing, and then you do your PTR, pointer PTR, and then for instance you would tab that in. I need to do an IN to let it know it's internet address, something like that, right? And then you would do something like the name of the server. In this case, it'd be localhost. Whatever. Does that make sense? And then that would be a reverse lookup. Well, okay. Okay. I might have to do that in reverse. A lot of times they just have it listed as single one. I'll show you online here for the real one. I have this written up in the real one, so let me show you the real one. I think it's still connecting, is it? I think. Yeah. There we are. Oh, that's cool. Real quick, let me just show you that dig on Google, so there's no confusion on this. So let's dig Google. Check it out. It's talking about the www.l.google.com. There we are. Here's your different servers for locations. Here's the CNAME. Here's the name that we type in, and it gets translated to its actual name. Makes sense? So on and so forth. And then I can run this in reverse if I want. I can dig -x here, space, and then I'm not typing this stuff in verbatim. And I really would like for McAfee to leave me alone. Alright. So with this, it lets me do that reverse lookup on the pointer. You see how we get that PTR entry? And this gives us our reverse lookup, and you can see how it's written here. So that's why I figured I'd have to write it like this inside the configuration file instead of run it like it normally, like 127. So I'd have to do like 1.0.0.27 .in-adder.arpa, etc., etc., something like that for it, and then it'd be a lookup properly. Okay, so let's look at an actual server that I have running on the internet, since that's what we really want to see anyways, right? All right, so if I look up AWS login console for me, all right, in Amazon Cloud, this is Amazon Cloud Services, this is AWS here, and they have this is the console management console, and then you get you have your username, password, all this stuff. There's journey is login to your console, so on and so forth. It's going to ask you for that whole fun stuff, and then you're going to put in. I'm not telling you that. All right, so from here, I have different ones. I have S3 for cloud storage or whatnot. I use this all the times for doing for videos and things of that nature, for storing them online. I have lots of stuff on here for as that goes. It's just cool. So for instance, here's the Moodle videos. I got all these different ones stored up here on Amazon Cloud to be served from here. And I get IP addresses, and well, not IP address. I get a web address to that file after I put it up there, which is cool. Route 53 is the DNS server. Your EC2 is what I'm actually running for the Apache web server. Well, a LAMP server, actually. It's a LAMP. It's got the MySQL database and all that fun stuff with Moodle running it. And I got some other stuff too. I develop other web pages into it and such. Hold on, let's get a second here. Continue. Alright, and so here I can launch additional servers if I want. I can look at the one that's currently running. I can look at my EBS keys and all this fun stuff. Here I can see the different locations, which current status here. I'm running on US East here, as far as that goes, available zones. If I click on my running one, It's an EBS volume. I do an EBS because that's the one that can be shut down and started up again without losing information. You always do EBS, elastic block something. I can't remember what it stands for. Storage, elastic block storage. If I click on this, it gives me information on my address, and then they have a dual IP address, which messes with you. I named it and everything, of course. So you have like your private DNS, and you got your public DNS, and you got two separate ones. The private one's an internal address inside of the actual cloud, virtualized cloud, which is separate from your external. This is your outside of the internal system where you communicate. This one you can communicate between server to server inside the network. This one here is for like people connecting to it outside the network, or general public, more or less, if you will. And then of course I said I didn't want people to type this whole fun thing in and then slash, type training or whatever. So I mean that's the option, right? So I set up a DNS address so it's a lot easier for obvious reasons. And it's got termination protection, it's got the platform, all this fun stuff here. Which particular instance server I installed, which is the Ubuntu server that I installed. Status checks here. I can do monitoring on it, etc., etc., etc. It's got all kinds of stuff, metrics, etc. if I want it. So I can actually check this out and see how I'm handling and how I'm doing on this. You're getting a decent amount of traffic, 4,000, wow. But anyways, all that. But all that aside, let's actually talk about the real one. It's of interest here, which is the Route 53, since we're talking about DNS servers. Thank you. I was wondering when it was going to do what I wanted. RDS is the database server, by the way. So you can get a MySQL server, Oracle, DB2, etc. in here, etc. So it's really cool. So you can grab those from there if you need them. CloudFront goes together with S3, which is basically your file. You tie CloudFront with S3, so you can basically do mass. We call it mass. Streaming, mass streaming. If you want to stream a video to umpteen different people, what CloudFront basically does is replicates the file to a server closest to the people accessing it, and thus brings down latency time. So that way it's super fast on access time. Best way to basically put out a file. There's other stuff on here I'm not getting into, but anyways, those are the most important ones. There's lots of other services and stuff. All right. So this is the actual DNS configuration. Alright, so I have this one here, for instance. And if I go to my record sets, where I actually created my records for my DNS server, you'll notice that this stuff is just like what we just went over. Oh, look, there's everything, just like what we did. Alright, so if I go in here to my A, this is my IPv4 address. This is the actual address that I got from Amazon Cloud for my virtualized server address on the internet. So I tied that to what's my DNS server here on the internet. This is my DNS server here through Amazon Cloud, and then the ICANN is pointing to this server address or set of addresses. Okay, so when someone goes to look up this www.hyperactive3d.com, it comes up with this address here. I did that by the IP4A here. If I look at my MX one set up, I have it going to mail.hyperactive3d.com, which actually points to the same server. I just like having a better name for it, so that way if I want to later on, I don't have to go and change a bunch of definitions. I just change the IP address to where it points to which one, and bam, it works. And then I don't have to change the rest of the definitions. Here is my NS, or my name servers. So here's all the different server locations of the DNS servers on Amazon Cloud that we use for mine. So you'll notice that I got these different locations. Here's the one from the UK, and there's one .org.net.com in UK. And so I got several that they're doing worldwide to cover all my hits here on this, which is pretty nice. Here's my pointer, or remember, this is reverse. So what this does is this takes the address and converts it to the name. Here's my start of authority, or start of authority. And here we can see the NS server. AWS DNS here, .org, etc., hostmaster, and then we got our different values. Remember what they were. Obviously, comments are nice, so I don't have that situation here, so I'm just typing it out as verbatim in short and compact form. Don't use short and compact form unless you have to. I think I have to for this. I don't think I can get away with putting comments in there and doing it the way I would like to do it. I'd like to do it with the parentheses and the commented out like I was doing in Linux, but I don't believe that is an option for me. Of course, TTL here for time to live right now, and it's set to 900 milliseconds. All right. So it even breaks it down here. So we have our authority domain here, authority domain, your domain of zone admin, zone serial number, refresh time, retry time, expire time, minimum TTL, or time to live. Make sense? All right. Here is the mail one. Check it out. It's the same IP address I had before, but again, all I had to do was redirect that. But essentially, I am targeting different servers if I like to. On my other configuration, I am actually targeting totally separate servers. I'm not going to go into that one because it's my clients, so I can't show you what my people are paying me money to set it up. So I'm not going to go show off their stuff. Anyways, here's this one right here for other mail, and this is the reverse address. Here's the www. So I have it set up to where they can go to hyperactive3d.com, or they can type in www.hyperactive3d.com. Or they can type in mail.hyperactive3d.com, which is great if I have something like Squirrel Mail set up, because essentially I can have a web mail interface for the server and provide it that way. Does that make sense? And then they can actually go and check their email through a web page. And again, this is the reverse lookup for that one too. And so we can see that there. I then set up a separate one for the other because I have two names registered from ICANN for this. So I then went in and set up the other one here, which is Hyperactive Store. And I did a similar thing here, but I did fewer setups on here. I just did the name server, I did the SOA, I did the A, and I did the PTR because I think those are the most important ones on it. Any questions? It's the same stuff over and over and over again. It's just essentially, again, you're taking a name, converting it to an IP address, and an IP address to a name. That's it. And the rest is performance tuning, how are we going to the mail server, how are we handling a name servers, other DNS servers, where are they at, so your NS, your CNAME, where you're basically renaming something, so that way you take a simple name and convert it to a more complicated name, and your PTR, again, is you're going from the address to the name. That's it. And of course, A is your IPv4, and quadruple A is your IPv6. Make sense? We're all good? All right, well, that essentially is the setup here. And no joke, sign out. That is basically what I wanted to show you and how that works. And it's pretty cool. Oh yeah, actually I should be able to check the resolve here. Let me do one more thing here while we still have the internet connection. If I go ahead and cat/etc, try to type in slash, type in shift instead, etc/resolve.conf, you'll notice that we get something totally different now. We now have name server 192.168.43.1. See that? That's the new address we got. So it's pretty cool. I can actually go in and edit this file and prove it to you that this will work. /etc/named, resolve.conf right here. Come in here. To edit, go ahead and put a pound sign in front of this thing. Remember, I can't have it in there. Name server here, 127.0.0.1, like so. Escape, Shift ZZ. All right, and then what I can do, if only, I can go somewhere. Like, oh, I don't know, blender.org, for instance, and resolved it. our DNS server works for resolving people's IP addresses to other web pages. Make sense?
So what's our lab?
You're going to be doing all those configuration files for the you're going to do the slave, cache, and master configuration files there, and then also the setup. Show that your dig and host works for localhost. Show me that all that works. Just basically like what I did in the video. There's a screenshot of that. Make sense? Okay, cool. And I guess one last thing to show, for the heck of it, I did actually write this stuff up as a text file to do this automatically. So I mean, like earlier when I was sitting there setting up the cache server, check it out. I actually have it come in and comment out the different things here. Listen, here the allow query, the DNSSEC here, and it hits all three at once, so on and so forth. So I actually did make it do that. I also had made it dig www.fedoraproject.org because they wanted me to do that as a test and this stupid thing. But dig yourself, dig localhost, whatever. And that works fine for me. And that's what I'm wanting to see. But yeah, just go in and configure those files, save them out, upload them. I don't need screenshots of the configuration files. Just upload configuration files, and do your setup. Take screenshots of your dig working and your host working. Do your reverse lookup, please. But that's about it. Any questions? Okay.